Welcome to this section. Now you will learn about a very helpful tool to work in Python, import statements. An import statement is a type of statement that we use to get access to the code that we wrote or find in another module. Code that was written in another Python file and that we want to use in our current file. Let's see why we need to use this type of statement. When we start working on our project, we typically start writing classes, functions, variables, and code in general with several different elements. But as the program grows in size and complexity, it becomes harder and harder to find the elements in our code. And organization is always key to develop maintainable programs. Imagine having to find a line of code in millions of lines of code. So what can we do about this? How can we improve the organization of our project? What we can do is split our code into multiple Python files and combine them. For that, we can use import statements. With an import statement, we can get access to the code in a file when we are working in another file. We keep the code separate, but we can still combine it to make the program that we need. This way, we can select the elements that we actually need to import to our program and keep our code organized. Let's see what we can learn about this type of statement in the documentation. In the documentation, we can go to the article, The Import System. This article explains in detail how import statements work. Let's read the first paragraph. Python code in one module gains access to the code in another module by the process of importing it. The import statement is the most common way of invoking the import machinery. The import statement combines two operations. It searches for the named module, and then it binds the result of the search to a name in the local scope. Then, right here, you can see more details about how import statements work and other elements of the import system in Python. For now, we will focus on import statements and how they work. If we go to EP08, the style guide for Python code, we can also click right here where it says imports, and we will see the guidelines for writing import statements in Python. Imports should usually be on separate lines. So if you're going to import more than one module, you should do it on separate lines, one per line. You can always go back to the style guide as you need to. It's called EP8, and you go to the section on imports. Inputs are always put at the top of the file, just after any module comments and docstrings, and before module globals and constants. Imports should be grouped in the following order: standard library imports, related third-party imports, and local application or library-specific imports. You should put a blank line between each group of imports. When importing a class from a class-containing module, it is usually okay to spell this: from my class, import my class. This is the name of the module of the Python file, and this is the name of the class. And if the class is at a different location, then you can specify the path to that location and import that specific class. And right here we have some recommendations for wildcard imports, which you will learn in detail in a lecture in this section. We also have some guidelines for package and module names. When we create modules, modules should have short, all lowercase names. Underscores can be used in the module name if it improves readability. The main advantages of dividing our programs into modules and then importing them with import statements are improving the project and code organization, grouping related classes, functions, and constants, reusing the code that we already wrote in the modules, and choosing which elements to import to the main program. We can choose the elements if we need to. We don't need to import all the elements of a module. Think about this for a moment. Have you ever wanted or needed to divide your project or program into multiple files? Let's see how you can write an import statement in Python. There are several alternatives depending on what you need to import. So the structure and the syntax of the statement will vary, and we will cover some variations that will be very helpful as you work with your Python programs. First, you need to remember that import statements should be the first statements in a Python module. This is very important. They are usually located at the very top of the file, if the program has any import statements. This is the most basic import statement that you can find. This type of import statement is used to import all the elements of the module that we specify: classes, functions, constants, and any other elements in the module. Notice the syntax. We write import, the import keyword, followed by a space, and then the name of the module that we want to import. This would be the name of our file or the path to our file, or it would also be the name of a built-in module, because Python also has several built-in modules that are installed automatically when you install Python. If we need to access an element from this imported module, then we will need to write the name of the module, followed by a dot, and then the name of the element. This is very important because we have to specify where the element is coming from, and this is also helpful to make your code more readable. Anyone who reads your code will know exactly where that element came from. Think about how you would write the import statement that is used to import the math module and access the pi constant. Try to write this in your code based on the syntax that you just learned. Pause the video and then come back. Welcome back. Right here we have the import statement and how we can access the pi constant. Import math at the very top of the file, and then when we need to use pi, we just write math, the name of the module, followed by a dot, and then the element, which is pi. Let's see this in our code. In our program, we can import the math module like this. We write import, followed by the name of the module. Right here, it is turning gray because we haven't used it so far in the program. So PyCharm is warning us that this module is not being used. But don't worry, we will use it in just a moment. We will define a circle class. This will be very simple, just to illustrate how to work with import statements. And our circle will have a radius. We will define a method findArea for the circle. And what do we need to know to find the area of the circle? We need to know the radius of the circle, and we also need the value of the constant pi. That is why we are importing the math module right here. To access or to work with the pi constant, we need to write something like this. The name of the module, which is math, followed by a dot, and then the name of the element. In this case, it's pi. So the formula is pi times the radius squared. And that is the basic formula to find the area of a circle. And you can see how helpful the import statement was. We have access to a constant that we wouldn't have access to if we didn't use the import statement. Now think about how you can call the randint function, which is a function from the random module, with this type of import statement. Think about this, pause the video, and then come back. Welcome back. To write this import statement, we would write import random, and then to call the function randint, we would use this syntax: the name of the module, followed by a dot, the name of the function, and then any arguments that the function requires. In this case, we have to specify the valid range of integers that we can use to generate the random integer. Great, so let's start writing our die class. We will write a die class that will have a roll die method. This method will assign a random value from 1 to 6 to the die that we are rolling. Okay? For that, we will need to import the random module. This is a module that contains functions that are very helpful to generate and work with random numbers and also to shuffle sequences. So we will use that in our code. Class die. The main characteristic of a die is its value. After we roll the die, the value at the very top of the die, the top face. So that is what we will assign as the value of the die. So we will say roll die. Rolling a die means changing the value of the die and selecting a random value from 1 to 6. So that is what we will do. We will generate a random value, and then we will assign that random value to the value of the die. The random value has to be between 1 and 6. So how can we do this? We just mention or write the random module, and we will need to call the randint function. This generates a random integer between a and b inclusive. So we need to specify the numbers 1 and 6 right here. It is recommended, according to the style guide, to have 2 blank lines between an import statement and any other elements in your program. So this is why PyCharm was warning us right here with a green line. It says, PEP8 expected 2 blank lines and only found 1. So this is another guideline that you should remember when you work with import statements. Great, so let's create a die instance. We say my die, and initially the value of the die will be, let's say, 4. We are setting this up in a way that we can specify the initial value of the die. We can also roll the die when we create it. That is another alternative. And we say my die, roll die. We're going to print the initial value of the die, and then we are going to roll the die and print the value again to see the change. If we save the file and we run the code, we see that the value of the die changed from 4 to 3. 3 was the random value generated right here with the randint function from the random module. So you can see how helpful it is to import modules, particularly the built-in modules are very, very helpful. If we run the code again, you can see that this is actually random. We get a different number each time we run the program. We got 4, then we got 2 again, then we got 1, so this is actually working as we expected. Great, so now you know how to work with this particular type of import statement, where we write import and the name of the module. You need to write the name of the module, followed by a dot, and then the name of the element that you want to use. If it's a function, we will call the function passing the arguments that the function requires. Now let's see another type of import statement that you can use. We can use this type of import statement to import only a specific element of the module that we specify. Previously, when we used import followed by the name of the module, we were importing all the elements of the module. But sometimes we only need to import a specific element of the module. So we can use this new syntax, this one right here. We write the keyword from, followed by the name of the module, the keyword import, and then the name of the element that we want to import. We're saying, from this module, import this element. To access the element in our code, previously we had to specify the name of the module, but now we can write just the name directly. A small tip is that this type of import statement can make the code more difficult to read and understand, since the module is not specified explicitly when you access the elements of the module, when you use the constants, when you call the functions. So we might take a little bit longer to detect visually where the elements are coming from. This is an example. We say from math, import pi. This is the name of the module, and this is the name of the element that we want to import. In this case, it is a constant. Now we can use pi directly in our code. Think about how we can use pi in the circle class that we defined, in the findArea method. Pause the video, try to implement this by modifying our circle class, and then come back. Use this new syntax for the import statement and modify how pi is accessed in our code. Here we have the example that we wrote in the previous video, where you learned this type of import statement. So let's refactor or change our code to use this new type of import statement. We write from math, import pi. We're saying, from this module, import this element. And how can we refer to this element now in our code? Well, we see an error because right here, we don't have to specify the name of the module explicitly. We just need to write the name of the element directly in our code, right here. We can do exactly the same with the random module to import randint. This is a function this time, it's not a constant, but you can refer to any element of the module right here. In this case, we can call the function directly without having to specify the name of the module. We just write randint and pass the necessary arguments. As a quick challenge, try to modify our previous example of a die where we used randint and use this new type of import statement. Pause the video, make the modifications, and then come back. This is our example with the die class. Previously, we were importing random with this import statement. So let's change this. From random, import randint. Okay? So now we have to use the name of the function directly, right here with the name of the module. We just call this function like we would call any other function in our code, passing the necessary arguments. So if we save the file and we run our code, we can see that the code still works exactly the same. We get the initial value of the die and we roll the die to get a new random value. This is another alternative syntax that you can use to import specific elements from a module. Now let's see a type of import statement that is typically called a wildcard import statement. This is the basic syntax of a wildcard import statement. We have from, the from keyword, then the name of the module, and then the keyword import, and finally we have right here an asterisk. With this asterisk, we are basically telling Python, hey, import everything that you have in the module directly, so I can access it without having to specify this name. Let's see what we can learn about this type of import statement in the Python documentation. If we go to PEP8, the style guide for Python code, and we click right here where it says imports, if we scroll down a little bit, we will see this paragraph. Wildcard imports with the form from the module import, basically everything because we have the asterisk. This type of import, wildcard imports, should be avoided, as they make it unclear which names are present in the namespace, confusing both readers and many automated tools. So in most cases, you should avoid using this type of import. It confuses both readers and automated tools. The documentation also mentions one defensible use case for this type of import, but this is very specialized and it's not something that you will commonly do in Python. Right here we have an example of a wildcard import. From math, import basically everything. When we write the asterisk, right here we are saying import everything that you have in this module. So we can refer to those elements directly. If we write pi right here, you can see that we don't get any errors, and the import statement is sort of like active now, instead of gray, because we are using an element that was imported from the math module. And notice that we don't have to specify where the element came from. We don't have to add math right here. If we run the code, we see the value for this constant, defined in the math module. We can also call functions like, for example, sine or cosine. And we can see these values right here. These functions would not be defined if we didn't have this import statement. You can see that if we remove this, we just see unresolved reference for each one of these elements. They were imported from the math module. But try to imagine doing this in a complex program, using all of these elements without specifying where they came from. This can quickly become very difficult to maintain, because when we see this in our code, we might not be completely certain of where this came from, of the module that this came from. This is why wildcard import statements are usually not recommended, because they can make your code more difficult to read and maintain. Welcome to this section. Now we will cover docstrings in Python. The name docstrings comes from two words, documentation and strings. Docstrings are basically string literals that we can use to document our code. And what do we mean by document? Well, we're basically describing a particular element of our code using docstrings. Let's see what we can learn about docstrings in the Python documentation. Right here, we're in the Python documentation, and we are particularly at an article called PEP257, Docstring Conventions. This PEP right here, this acronym, means Python Enhancement Proposal. This is just an article that details the conventions that we have to use to write docstrings and what they are used for. It's very interesting. You can go to this article and click right here on what is a docstring. Let's see what it says. A docstring is a string literal that occurs as the first statement in a module, a function, a class, or a method definition. Such a docstring becomes the doc special attribute on that object. Okay, we will talk about this in a video during this section. Docstrings are connected to the element they describe with this special attribute. All modules should normally have docstrings, and all functions and classes exported by a module should also have docstrings. Public methods, including the init constructor, should also have docstrings. The conventions also recommend that for consistency, we should always use triple double quotes around docstrings. And it also mentions that we should use raw triple double quotes if you use any backslashes in your docstrings. For Unicode docstrings, you should add a U before the triple double quotes, okay? This is just the basic syntax of a docstring. An overview, we will go through the syntax again in a video during this section. There are two forms of docstrings, one-liners and multi-line docstrings. So based on what we just read, docstrings are human-readable comments that explain the purpose and the logic of a particular element of our code. For example, a function, a module, a class, or a method. They work sort of like a manual that anyone who wants to use that element can read and learn how to use it. They describe the purpose and the logic of the element, what the user has to know to be able to interact with that element and use it in the code. In the case of functions and methods, they also describe their arguments. A brief description of each one of them is usually included and their data types, so the user can know what data types are expected to call the function or the method. The return value can also be described, and this description can also contain relevant information. For example, valid range of values that you can pass as the arguments, and any exceptions that might be raised if you pass an invalid value to the method or the function. These are some key takeaways from what we read. Docstrings are the first statement in a class, a method, a module, or a function. And they should be included in all public methods of a class, including init, where we initialize the instance attributes. So now let's see the difference between docstrings and comments, because they actually start to sound very familiar, right? Well, one of the main differences between docstrings and comments is that docstrings are linked to the element that they describe. We will see an example of this during the section. And comments are not linked to any part of the code. Actually, they are removed behind the scenes and they are not considered part of the code when the program runs. Another key difference is that docstrings can be used to generate documentation automatically using certain tools. But comments, they cannot be used to generate documentation automatically. They are not actually considered part of the code and they cannot be detected by any automatic tool to generate documentation. And finally, docstrings can be read with the help function in the interactive shell, and basically when you write a program in Python, you can learn more about an element by using the help function, but in comments you can only read them directly in the source code. You have to open the file and go to the specific line of the comment. These are the main differences between docstrings and comments, so you can see that they are actually quite different. There are also two types of docstrings that you have to be aware of. We have one-line docstrings and multi-line docstrings, depending on the level of detail and description that you want to add to your documentation. We will see both of them in detail during this section, and you will learn how to write them and what type of information to include. Awesome! Take a moment to analyze why docstrings are important. Have you ever seen a method or a function and wondered how it works, and wish that you had something that would just explain that to you in plain language instead of having to analyze the code line by line? Well, that is what docstrings are for. So by the end of this section, you will be able to write that documentation for you and for other developers. Now let's see how you can write docstrings in Python. There are two types of docstrings, one-line docstrings and multi-line docstrings, depending on the level of detail that you want to add to your documentation. One-line docstrings are typically used to document very simple methods and functions. Let's see what we can find in the documentation about this type of docstring. If we go to PEP 257, Docstring Conventions, we can go right here to the table of contents and click on one-line docstrings. We will go immediately to this part of the article, where it says, one-liners are for really obvious cases, okay? They should really fit on one line. So that is why we use them for really obvious cases. For example, right here we can see a function. Notice this right here. This is the one-line docstring. Let's read the notes. We can see that triple double quotes are used even though the string fits on one line. This makes it easy to later expand it, okay? The closing quotes are on the same line as the opening quotes. You can see this right here. On the same line. This looks better for one-liners. There is no blank line either before or after the docstring. Right here we have the docstring, we have the function header, and right here below we have the body. So we don't see any blank lines before or after the docstring. The docstring is a phrase that ends in a period. Right here we have the period. It's very important to include it if you want to follow the Python style guide. The description prescribes the function or method's effect as a command. Okay, this is recommended by the Python style guide. For example, do this, return that. It should not be written as a description according to this particular guide. It says don't write returns the path name. Write instead return. Not returns, return, like a command. This also says that the one-line docstring should not be a signature that reiterates the function or method parameters, which can be obtained by introspection. So it basically says that we shouldn't write something like this, where you're basically just writing what the user can detect by simply reading the code. We know that it is a function that takes two parameters, a and b. We can see this right here directly. And we might know from the code that the result is a list. So basically, this is not adding any important information for the user of the function, for yourself or the developer who is going to work with this function. The docstring's main purpose is to add important information for the user. Right here we see below, referring to this type of docstring, it says that it is only appropriate for C functions such as built-ins, where introspection is not possible. However, the nature of the return value cannot be determined by introspection, so it should be mentioned, okay? The preferred form for such a docstring would be something like this. Do X, do something, and return a list, okay? Of course, we should replace do X by something that is useful, a useful description, like it says right here. Okay, so these are the basic guidelines for one-line docstrings in the documentation. Right here, we have an example of a very simple function that adds two numbers, a and b, and it returns that sum. Let's say that we want to add a docstring. We just click enter after the first line, the function header, and we are going to write triple double quotes, okay? PyCharm automatically adds the closing quotes right here, and in the middle, we just have to add some spaces and start writing our docstring, our description. We might say, for example, return the sum of A and B. We end with a dot, and we don't have any blank spaces right here after the dot. We just write the closing quotes on the same line as the opening quotes. We write a brief description of the function in a user-friendly format, and we indicate what the function does. It returns the sum of A and B. Right here, we have an example of a function that prints Floyd's triangle, a particular pattern with the shape of a triangle where each element is a number and the number is incremented by 1. To add a docstring to describe this function, we just need to write triple double quotes, the opening quotes and the closing quotes, and in the middle we just write the description. We say print Floyd's triangle with n rows. This is very helpful for the user because we know what the function does and how it will be customized according to the argument that we pass. We are referring to this argument and specifying what this means. This is the number of rows that will be printed by the function for this pattern. we end the line with a dot, and we have the closing quotes on the same line as the opening quotes. Awesome. So these are the key guidelines that you need to follow to write one-line docstrings. Always remember to use triple double quotes. Remember that the closing quotes should always be on the same line as the opening quotes. You should end the line with a period. Write the effect as a command. It is recommended to write the effect as a command. For example, return, add, print. You should also remember to avoid adding a blank line before or after the docstring. The docstring should be immediately after the header and immediately before the body of the function or method or element that you are describing. And you should also remember to mention the return value and describe it. If you think that it will be helpful for a person trying to use that element, then include it in the documentation. Now let's dive into multi-line docstrings. They are used to document more detailed and complex methods, classes, and modules, or even functions, if they needed more detailed documentation. Their basic structure is this one right here. We start with a summary line, which is basically the same as writing a one-line docstring. It should follow most of the same rules. Then it should have a blank line, and after that blank line, a more elaborate description of the element. Let's go to the documentation to see the guidelines and some examples. Right here, if we go to PEP 257 Docstring Conventions, we can go to the part of the article where it says multi-line docstrings. Right here, we click on the table of contents, and that will take us to this part of the article where we can learn more about multi-line docstrings. Multi-line docstrings consist of a summary line, just like a one-line docstring, followed by a blank line, followed by a more elaborate description. The summary line may be used by automatic indexing tools. It is important that it fits on one line and it is separated from the rest of the docstring by a blank line. The summary line may be on the same line as the opening quotes or on the next line. So this is up to you. You can start writing the docstring on the same line as the opening quotes, like we did with one-line docstrings, or you can start writing it on the next line as well. The entire docstring is indented at the same level as the quotes at its first line. You can see the example below right here. We have the opening quotes right here, we have the closing quotes right here, and the content of the docstring, which is this right here, is indented at the same level as the quotes, the opening and closing quotes. Right here we see the guidelines for docstrings for different types of elements. We see to document a class, to document a script, a module, and right here we have what we will be focusing on during this video. Functions are methods. The docstring for a function or a method should summarize its behavior and document its arguments, return values, side effects, exceptions raised, and restrictions on when it can be called. All if applicable, of course. Optional arguments should also be indicated, and it should be documented whether keyword arguments are part of the interface of the method or function. Right here we see what the docstrings for a class should be like. We will learn more about this when we cover docstrings in classes during this section. Okay, so right here we can see this example of a docstring in the documentation. We have a function complex. We can know how the function works and what arguments it takes just by looking at the documentation, the docstrings. We know that it forms a complex number, and it has two keyword arguments, real and imaginary. The real part of the number, which by default is 0.0, and the imaginary part of the number, which by default is 0.0, okay? So this is basically giving us a human-readable description, a user-friendly description of its behavior, arguments, and return value. For methods and functions that require multi-line docstrings, you should document the arguments that they take with a brief description and their data types to indicate the user how that method or function should be called. It should also mention any optional arguments and the return value. It should mention any side effects that the function or method may cause on an argument or on a value if it mutates, for example, a list, and any exceptions that might be raised if the arguments are not valid or if the process fails at some point. That covers most of the important aspects of a method or a function. Right here, let's see how we can write a multi-line docstring for this function, this particular function. We're using functions as examples right here, but this also applies directly to methods. So all of these guidelines apply to methods as well. In this case, this function makes a frequency dictionary. A dictionary that maps each element in the sequence that we pass as argument to its corresponding frequency, how many times that element occurs in the sequence. So we want to write something that will be helpful for the user to understand what this function does without actually having to read the code. Let's do that. Since this is going to be a multi-line docstring, we can write the quotes on different lines. If we write the quotes on different lines right here, then we can start with the initial line. The first line is just like a one-line docstring, where we write a one-line description or summary line of what the function does. It says, return a dictionary that maps each element in sequence to its frequency. Okay? We have to end this line with a dot, like we're doing right here. After that, we have to add a blank line, and then we can start writing the more detailed description of the function. Let's add more details. Create a dictionary that maps each element in the list sequence to the number of times the element occurs in the list. So we're specifying that the sequence is a list right here. We're adding more details. The element will be the key of the key value pair in the dictionary, and its frequency will be the value of the key value pair. We're writing a lot of details right here to help the user understand how the function works without actually reading the code. We can also add a subsection or more than one subsections to guide the user. For example, we can describe the arguments that it takes. Arguments, or argument in this case, since this function just takes one argument. So we say argument and we write sequence. This argument is a list of values, okay? These values have to be of an immutable data type because they will be assigned as keys of the dictionary. As the keys of the dictionary. For example, they can be integers, booleans, tuples, or strings. Great, now we described in detail the type of argument that the function can take. And we also gave some examples of the data types that the function can work with. We described what the function can take as input, and we also have to explain to the user what value will be returned. We might say the return value is a dictionary that maps each element in the list to its frequency. For example, this function call, make frequency dict, passing the list 16262, returns this dictionary. 1 is mapped to the value 1, 6 is mapped to the value 2, and 2 is mapped to the value 2. The user has a better idea of how the function works and how that can be used in the program. We also have to warn the user of any exceptions that the function may raise. In this case, we have an example of raising a value error. We say that the list cannot be empty if the sequence is empty, okay? So this function might raise a value error, and we explain why. If the list is empty. Now we remove these extra blank lines right here, and we have the closing quotes. They're closing triple double quotes. Notice how helpful this documentation can be. We have our multi-line docstring right here. It is very detailed and it really helps the user to understand how the function works what type of arguments it takes, and the return value without actually having to read the code. In this case, we have a small function, but imagine how helpful this will be if the function is more complex and if the code is a little bit more difficult to read or understand. Great, so we covered methods and functions. Now for classes. For classes, we need to include in the documentation what the class represents. We also need to mention any public methods that the class has that we can call from outside of the class, any class and instance variables that are public in the class, and the effects of inheritance on the class. You will learn more about this in the coming lecture, so when you're ready, go to the next video where you will see how you can document classes in Python. Documenting your classes in Python is very important because it can help you and other developers know how to work with and interact with the objects that you create from the class. So let's have a quick tour of the documentation to see what it says about documenting classes. Right here, we are in the Python documentation, in PEP 257 Docstring Conventions. If we go to the table of contents and we right-click on multi-line docstrings, we can see this paragraph right here. The docstring for a class should summarize its behavior and list the public methods and instance variables. If the class is intended to be subclassed and has additional interface for subclasses, then this interface should be listed separately in the docstring. The class constructor should be documented in the docstring for its init method, so the init method should be documented with a docstring. Individual methods should be documented by their own docstring. If a class subclasses another class and its behavior is mostly inherited from that class, its docstring should mention this and summarize the differences. You should use the term override to indicate that a subclass method replaces a superclass method and does not call the superclass method. And use the verb extend to indicate that a subclass method calls the superclass method, in addition to its own behavior. So we have two terms for the docstring, override and extend. Okay? So the key takeaways are that the class constructor should be documented in the docstring for its init method. Individual methods should all have their own docstring, particularly public methods. And finally, if a class subclasses another class and its behavior is mostly inherited from that class, its docstring should mention this and summarize the differences. Right here we have a backpack class. The class has three methods, and it also has the init method. We can see that initially a backpack instance has an empty list of items. We can add an item, remove an item, and check if the backpack contains an item, or if it has an item, okay? So let's start documenting this class to help the user of the class know more about the type of objects that he or she can create and how to interact with the objects. We start by using triple double quotes. We close the docstring with triple double quotes, and we start writing the documentation. Let's see. First, we write a summary line of what the class represents. We can say, for example, a class that represents a backpack. Okay, we end the line with a dot. This is like a summary line for the class. After that, it depends on the style that you're using for the docstring. One alternative could be separating the different parts of the documentation or of the docstring, depending on the type of description. Right here we have, for example, a section for the attributes. And we start describing the attributes that will be created for each instance of the backpack class. We say items is of type list, and it represents the list of items in the backpack. This is initially empty. Okay? So now we know that when we create an instance of backpack, we will have this attribute, this public attribute in the class. Now we have to list the methods of the class and provide a short one-line description of each one of them. You can also include the parameters of each of one of these methods so the user can have a better idea of how to call these methods. So let's list the methods. We have add item, and we say add item, self and item, And you may write the description right here on the same line, or you may write it on the next line indented. So we know that this description belongs to this method. Let's say that the purpose of this method is to add the item to the backpack. Okay? Like this. It's just a short description, and the documentation recommends writing the effect as a command, add. Then we have remove item. This method takes self and item as arguments. So we say self and item. Remove the item from the backpack. And finally, we have the third method, hasItem with self and item, like this. And this method returns true or false based on whether the backpack contains the item. So let's write it like this. We can, for example, write it like this. Return true if the item is in the backpack. Else, return false. This really depends on what you want to write as the description of the method. And the format of the docstring really varies, okay? So you may find these elements in a different format. But this is just one alternative, and I think it really looks nice because we are dividing the content of the docstring into different sections. Notice that we are aligning the titles of the sections with the opening and closing quotes, and that is recommended by the docstring conventions. Awesome, so now we have our multi-line docstring for a class. We have a summary line of what the class represents, we have the attributes, and we have the methods. Right here, we are writing attribute in singular because there is only one attribute, but you would write attributes if you have more than one attribute. There are many different styles to write docstrings. Another important aspect of the documentation is documenting properties in a class. In this case, you should only document the getters of the property and include relevant information from the setters, if applicable, okay? So if a property has a getter and a setter, you will only write a docstring in the getter. And that one docstring should include all the relevant information for both of these methods. Okay, so now we're going to have one more practical example of how we can document a Python class. Right here we have a circle class. We are importing the math module because right here we will be using the pi constant from the module to find the area and the perimeter of the circle. So that is why we are importing this module. We have the class, we have the constructor with two arguments, radius and color. We're going to create these two attributes for the instances. Right here we have properties. The radius, but radius will only have a getter. We don't want to change the radius of the circle, but we do want to provide a setter for the color. We're going to be able to get the color and set the color with a new color right here. We also have another property, the diameter. We are not defining this as an instance attribute right here. We're actually defining it as a property because we are going to take the radius and multiply it by 2, and that will be the diameter right here. Because in case that someday we might want to make the radius variable so we can reassign or change the value of the radius, the diameter will be calculated dynamically with the current value of the radius. We also have the find area method. It finds the area of the circle and the perimeter, 2 pi times the radius. We're going to document this class with the class docstring, and we're going to add docstrings to each one of these methods. So let's get started. First of all, we go to the class header, and on the next line, we write the opening, triple double quotes, and the closing, triple double quotes. The first line should be a summary line, so we can write a class that represents a circle. Okay? We could write this on the same line or on the next line. This is allowed, both cases are allowed by the docstring conventions in Python. Now let's add a category, attributes. And what attributes do we have for each one of the circles that we will create? We have first a radius, which is going to be a float. We're going to define this as a float, and we say it's the distance from the center of the circle to its circumference. Okay, to the circumference. Then we have the color attribute, which is going to be a string. This will be the color of the circle. described with a string, of course. And we also have the diameter, which is going to be a float. This is the distance through the center of the circle from one side to the other. These are all the attributes of the class. This is a property, but we are including this in the section for the attributes. We also have these methods. We have find area right here below. We have find area, and this method only takes self as the argument. We can write self. In some styles, you will see that self is omitted. That depends on the style that you're using and what your team agrees for the documentation. So we say, return the area of the circle. We're using the command. Right here, we're writing this as a command because of the guidelines in the docstring conventions. And we also have find perimeter, self, right here. We say return the perimeter of the circle. And we remove these extra blank lines right here and this extra blank line right here. And we have our class documentation. You could be more descriptive, you can add more details or change the structure of the docstring, but this is just a basic idea of what you can include right here. Now let's go to the init method. We have to document the constructor as well. So let's write our quotes right here and we say, the purpose of this method is to initialize an instance of the circle class. What are the arguments? Well, we have these arguments right here. We have the radius, which is a float, and we are going to write the same description that we wrote in the class description. The distance from the center of the circle to its circumference. Like this. And we also have the color, which is another argument right here. The color is a string, the color of the circle. We could add more details or even specify a format for the string if that is required. Okay? Now we have our documentation for the init method. So let's start documenting our properties right here. We have radius and we have color. For radius, we will write a simple docstring. We say, return the radius of the circle. And we might want to add a short description of what the radius represents. This is a float that represents the distance from the center of the circle to its circumference. Like this, okay? Now for the color, we can also be more specific right here in the property and specify the format of the string. We say, return the color of the circle represented as a string. And we can say, for example, the color is described by a string that must be capitalized. Let's say that we want the string to be capitalized. So we can give an example. For example, red, blue, green, yellow. And those are our examples. We might remove this since right here we're saying that it's represented by a string, okay? Return the color of the circle, and right here we provide more details for that property. This part of the documentation also applies to the setter of the property because we're specifying what the value should be like. It should be capitalized, and these are some examples of values that we can assign as the new color. So we're basically documenting the getter and the setter in one docstring, and that is what you should do. You should document the getter and the setter in the same docstring in the getter. Okay? We don't write any docstrings for the setter, so we go to the diameter. In the diameter, let's write return the diameter of the circle. And we say this is a float that represents the distance through the center of the circle from one side to the other. We just provide more details about this value. And we're done, basically, documenting the properties. So now we have to go to the methods. We go to find area. So what are we doing with this method? We say find and return the area of a circle. The area is calculated with the circle radius using the formula or applying the formula pi times radius squared. Great, so now let's go to our final method, find perimeter. We say find and return the perimeter of a circle. The perimeter is calculated with the circle radius using the formula. What formula are we using right here? 2 times pi times the radius. 2 times pi times the radius, okay? Great, so now we have our class completely documented. As you can see right here, we have the documentation or the docstring for the class. We have the docstring for the constructor, a docstring for each one of the properties, and we also have a docstring for each one of the methods. Great, so let's see how this works with the doc attribute and with the help function. Let's see how we can find or read the documentation for the circle class. We say help, and right here we are going to find or read the documentation for circle. Okay, let's save the file and run the code and see what we get as the output. Right here you can see that we get the documentation for the circle class, the class that we just described. Help on class circle in module main. Circle with radius and color. A class that represents a circle, and this is actually what we wrote in our docstring. We have the attributes, their description, we have the methods and their description, and this is generated automatically when we use the help function. We see this. Init, initialize an instance of circle, and right here we can see the arguments of init, the documentation that we wrote. Right here we also see a documentation for the methods find area and find perimeter. We see the read-only properties that were defined, the diameter. We can see that the docstrings that we wrote are right here, and right here the radius. We can make this documentation for the properties more concise and just describe the value directly. This is another option, making this more concise. And we see some data descriptors, including color. Return the color of the circle. The color is described by a string that must be capitalized, and we see the examples that we included in the documentation. Awesome, so we can read this with the help function. And we can also print, for example, the value of the doc special attribute. So right here, we only see the documentation for the class. Awesome, now you know how to document your classes, your properties, and your methods in Python. Great work so far during the course. Now let's see how docstrings are related to the special attribute doc. You will see that doc is actually what links docstrings to the corresponding element in the code. When you write a docstring as the first element of a function, method, module, or class, that docstring is automatically linked to that element through the doc attribute. This is a special attribute because you can see that right here we have 2 leading and 2 trailing underscores. This is what we call a special attribute. You can access the docstring in the interactive shell and basically in any Python interpreter with the help function that we have right here. We will use this in PyCharm. When you call the function and you pass the name of the element, for example, the name add, right here within parentheses as the argument, you will see the docstring for that element if it exists. You can learn more about the element and how to work with it with the help function and with the doc attribute. Now let's see how you can access docstrings for built-in methods that you commonly work with in Python. And then you will see how we can customize them. But before we do that, think about how you can access the special attribute doc. Try it. It's the same syntax that we have been using so far to access an attribute. Now we're just adding the leading and trailing underscores. Pause the video for a moment and then come back so we can try this in our code. Let's read the documentation for some built-in methods that you have been working with so far in Python since you started learning how to code. But now you will learn how to access their docstrings to learn even more about them. Let's start with the length function. This is a function that you probably used like 1,000,000 times to get the length of a sequence. There are 2 alternatives. We can use the help function that we have right here. If we write help and within parentheses we pass the name of the function, we will see its docstring directly, like this. If we save the file and we run the code, we can see its documentation. We see help on built-in function length in the module built-ins. So we know that this is the name of the module that this function belongs to. And we see right here its arguments. We see that it takes an object. And it says, return the number of items in a container. Awesome, right? We can use the help function to access that. Or we can also write print the name of the function and the special attribute dog that we have right here. You can see that it has 2 leading and 2 trailing underscores. We click enter or we can write it manually. And if we run the code, we just see the documentation return the number of items in a container. So you can see that the documentation, the docstring, is assigned to this special attribute. And that is an attribute of the object, of the function, of the class, of the module, or the method. Awesome, let's try this again with the help function, but now let's see what it says about the sorted function. Like this. We see help on built-in function sorted in the module built-ins. Right here, we see the arguments that the function can take. Iterable, because it takes an iterable to sort it, and then we see some optional arguments, key and reverse. And these are their default values. It says return a new list containing all items from the iterable in ascending order. So you can see the purpose of the function right here. And you can see that right here, the effect of the function is written as a command, return, like we read in the docstring conventions. Right here, we also have more information about the function. So right here, we are having more details about the optional arguments, key and reverse. Awesome. Let's try this now with a method, because so far our examples have been functions. Let's say that we want to get the documentation for the sort method of a list, of the list class. We write the name of the class, which is list, and then we write the name of the method, which is sort. But instead of writing these empty parentheses, like when we call a method, we're going to omit them. Okay? We're just writing the name of the class dot the name of the method. And since we are using the help function, that will return the documentation. It will show us the documentation for that method. You can see this right here, help on method descriptor. Sort. We can see that it takes self, and right here it has some optional arguments, and we can see a description, the summary line. Sort the list in ascending order and return none. Okay? We can also specify that a method returns none in our documentation. We see that the sort is in place. It warns us that the list itself is modified and stable. The order of 2 equals elements is maintained. So you can see that all of these optional arguments are explained in the corresponding paragraph, and right here we have a brief summary and more details. So these are great examples of how you can start writing your documentation for the methods of your class. Now let's see how this works with a function and its doc attribute, the special attribute, and the help function. This is equivalent for methods of the class. You just have to add the name of the class before the name of the method if it's a method. Right here we have a function. We have the add function with this one-line docstring. Let's say that we want to access the documentation for this function. We would just write help and add right here. If we save the file and we run the code, we can see this right here, help on function add in the module main. We see the name of the method, its 2 arguments, and we see that it returns the sum of A and B. Awesome, this is the documentation, the docstring that we wrote right here. So using the help function, we can access this, but we can also use the print statement to access the doc attribute, this attribute right here, and that will almost be equivalent in this case. That will just return this line without any additional information like this. We see return the sum of A and B. Now, if this was part of a class, you would just add the name of the class right here, like this. For example, the name of the class .add.doc. Remember that to access the documentation from a class, you just need to add the name of the class before the name of the method, like this, for example, list.sort, and that will return the documentation of the sort method from the list class. You could also write, for example, let's say tuple.count. the count method applied to tuples, like this. You can see that count returns the number of occurrences of value that we have right here as an argument. So you just have to specify the name of the class before the name of the method. For example, string and the method capitalize. This will return the documentation. Return a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. This would be exactly the same with your class, your custom class. You would just write the name of the class right here and the name of the method right here, and that would return the documentation. Or alternatively, you could use the print statement and just write the name of the class followed by the name of the method and the special attribute doc, like this, okay? This returns the documentation directly, like this. Awesome, now you know the connection between Docstrings and the special attribute doc and how we can access the documentation with the help function.